Thank you for the invitation to present the biogas sector in Denmark. I've been working in the biogas sector for almost 30 years. So when we are talking about the development in the biogas sector, it doesn't work, sorry. Yeah, just to present the Danish Biogas Association, we are the association for all the stakeholders in the biogas sector in Denmark, both the producers of biogas, the owners of the biogas plants, we have the biomass suppliers, the users of the digestate as fertilizer, and we have the technology suppliers, consultants, and so on. And we are working to promote the production and the use of biogas as one leg, the energy leg, but the other leg, the circular economy leg, has the same importance. So when we look into the development in biogas in Denmark, you can see on the left-hand side the production in biogas. You can see not much happened for many years, but the recent 10 years the biogas production has increased very dramatically. On the right-hand side you can see the origin of the biogas, and you can see that 30 years ago, 60% of the biogas came from collecting methane from landfills, it came from wastewater treatment plants, and only 40% came from agricultural-based biogas plants. Now it's more than 95% of the biogas that is coming from agricultural-based biogas plants. Last year, 40% of the natural gas consumption in Denmark had been substituted by biogas injected into the gas grid. And also last year, 40% of all livestock manure in Denmark was digested in biogas plants. So the Danish model is that we take livestock manure, it might be liquid slurry or deep litter, solid manure, and we mix that with all kinds of organic residues, source-separated household waste, waste from industry, and waste from agriculture. And in this co-digestion process, we both make it easier to digest the livestock manure, but especially we have the platform for the recirculation of the nutrients in the waste. Because a biogas plant, in our opinion, is first and foremost a fertilizer factory. We've turned livestock manure into a better fertilizer, and we recirculate all the nutrients from the waste in the society. And it's also a way of nutrient supply, especially for the organic farmers who cannot buy chemical fertilizers. And then, of course, we also have the byproduct, the mixture of CO2 and biomethane. It's very important in the green transition. We know that electrification, the windmills and the solar panels will be the backbone of the decarbonized energy system in the future. But the biogas sector is very important because we can deliver the electricity in the system when there's no sun or no wind. And we can also make the green transition in those sectors that is very difficult to electrify. So based on the residues, we can reduce the climatic impact, we can reduce the environmental footprint of food production, and we can make a more stable energy system. The feedstock in the Danish biogas plants is on the left-hand side. You can see more than 75% of the feedstock is livestock manure, and slightly more than 1/3 of the produced biogas comes from livestock manure. Approximately 20% of the feedstock is waste from dairy, slaughterhouses, and so on. It might be byproducts from the glycerin from the biodiesel production, and source-separated household waste. It's 20% of the feedstock and little less than half of the produced gas. Actually, this share is decreasing, and the share of gas from livestock manure is increasing. The red one is energy crops grown with the only purpose of producing energy. It's a minor source of biogas production in Denmark. It's less than 4%. It used to be maize, but from August the 1st this year, we are not allowed to use maize at all. Therefore, the conclusion is that biogas production in Denmark is based on residues from agriculture, from industry, and from households. And you can see that we are cleaning up behind the society and behind the food production. When we look into the potential of biogas production, you can see the 2040 column that the total biomethane potential in liquid manure, deep litter, industrial waste, food waste is 50 petajoules. On top of that, we have a huge resource in the straw from the wheat and barley production, an additional 45 petajoules. So the total biomethane potential in residues in Denmark is 94 petajoules. That year, when this analysis was made, the total Danish natural gas consumption was 90 petajoules. So the conclusion is that we do have resources to fully substitute natural gas, and on top of that, we can also utilize the CO2 content of the biogas, turning that into electromethane, and then we could add another 60 or 70 petajoules on top of that. And what we are doing is that we produce storable renewable energy. 10 years ago, we used the biogas only in the CHP plants to produce electricity and district heating. Right now, more than 85% of the feedstock of the biogas is upgraded and injected into the gas grid. So we produce renewable, storable energy. The official forecast from the Danish Energy Agency is that within the next 5 or 6 years, we will have a 100% green gas supply in Denmark. That's because the natural gas consumption decreases due to the electrification, but mainly because the biogas production will increase. So when we look on a couple of biogas plants, you can see upper left, a biogas plant in the eastern part of Denmark established by 20 local farmers 30 years ago. The biogas was used in local CHP plant. They installed the big white yellow bellow to store the gas for 8 hours so they could utilize the gas in those hours with the high electricity prices. Bottom left, a cooperatively owned biogas plant established 35 years ago in the southern part of Denmark. They also switched from CSP into upgrading, and it has been enlarged. Bottom right, a rather new biogas plant in the middle of Jutland, established by local investors. You can see the first biogas plants were established by local farmers to solve their challenges with the environmental legislation. Now it's local investors that went into the business. And actually now that biogas plant has been bought by what we in Denmark is calling the Billionaires Club. We don't know who they are, but we know they are quite wealthy and they have decided to invest in the biogas sector. Upper right, it's a traditional farm-scale biogas plant established on a pig farm up north in Denmark, established in the year 2000. When you see that biogas plant today, you can see it's totally different. He has the windmills, this farmer, and now they are off-grid producing hydrogen, and the hydrogen is injected directly into the digesters to increase the methane share. So he's producing biomethane, electromethane, and of course CO2. And the electromethane is liquefied and driven to Germany for the German transportation sector. This, with the service to the farmers to collect the methane, is very important. In this map on the right-hand side, you can see how much the emission of methane from the livestock farms has been reduced when they are part of a biogas plant. And this is very important in regard to what has happened in Denmark the recent year. 1 year ago, the parliament decided to introduce a carbon tax on biological processes. This means that from 2030, each farmer has to pay a carbon tax of 40 euros per ton of CO2 equivalent that is emitted from the livestock manure. And of course, this will be very costly for the farmer. Here again, we can be the solution to this. If we get the manure on a weekly basis or preferably on a daily basis, then we can actually help the farmer so that he doesn't need to pay this tax. And of course, this is the objective, not to pay the tax, but to reduce the emission of greenhouse gases. The other thing is that we need to meet the European Union conditions to reduce the leaching of nitrates. Therefore, as part of this political agreement, it has been decided that we need to have a turnover of the land. The farmers need to stop growing wheat and barley near the environmentally sensitive areas. It should perhaps go into natural habitats or into forests. But while we are waiting on that, then the easy thing is that the farmers will switch from barley and wheat into grass. And if he doesn't have any cattle, then he cannot use that for anything. But again, the biogas plants can be a solution. We can use the grass from those areas grown with grass to protect the aquatic environment, produce more gas, but we can also recirculate the nutrients from the environmentally sensitive areas. So we have the circular economy. What we are looking into now is that with the increasing share of straw in the feedstocks, then we need to have a post-processing with the separation, and the liquid fraction can go out as a fertilizer. The solid fraction could perhaps go into a pyrolysis plant to have a long-time storage of the carbon in the soil. We used to use all the biogas in the CHP plants. Now more than 85% is being upgraded. And we then have the CO2 content, and the CO2 content will be the next big. If you go to Denmark and have a beer or a soft drink, then the bubbles will come from a biogas plant. It's a biogenic bubble in the soft drinks in Denmark, and remember, that's a quality issue. But we have to integrate with the energy sector and upgrade the electricity into fuels and into plastics in the future. What has paved the way is that, of course, we have had the economic incentives, but we also have had help from the society. The municipalities had the obligation for the planning of the placing of biogas plants, and we have had standard requirements for the permits. We have had the grid access, and we have a very pragmatic way of handling the digestate. If less than 25% of the feedstock is waste on a dry matter basis, then it's handled purely as livestock manure. And just to wrap up with the final conclusion is the letter 40, that is the conclusion in my presentation. As you have seen, the two first 40, that is the share of biogas in the gas grid and the share of livestock manure that is being digested in Danish biogas plants. When I started in the biogas sector 30 years ago, the total Danish biogas production was 40 million cubic meters. The newest biogas plant inaugurated in Denmark has themselves an annual production of biomethane of 40 million cubic meters. And the final 40 is that 40 years ago, the first biogas plant was constructed, which is still in operation. So we have a long tradition in how, when the different policy areas work together, that we can promote the biogas sector, and we would love to share that experience with you here in Spain and in other countries. Thank you.